Physics Part 331. Some of the properties of magnets have been known for many centuries. The ancient Greeks discovered an iron ore called lodestone, which, when hung from a thread, would come to rest always pointing in the same direction. This was the basis of the magnetic compass, which has been in use since about 1500 BC as a means of navigation. The magnetic compass is dependent on the fact that freely suspended magnet will come to rest pointing north-south. The ends of the magnet are said to be the poles. The pole pointing to north is referred as the north-seeking pole, North Pole, and the other is called the south-seeking pole, South Pole. It is now known that a compass behaves in this way because the Earth is itself a magnet. Magnets exert forces on each other. These forces of either attraction or repulsion are used in many children's toys. Indoor catches and fridge magnets. The effects of forces may be summarized in the law of magnets, like poles repulse and unlike poles attract. The law of magnets implies that around any magnet there is a region where a magnetic pole will experience a force. This region is known as a magnetic field. Magnetic fields are not visible, but they may be represented by lines of magnetic force or magnetic field lines or magnetic flux. A simple way of imaging magnetic field lines is to think of one such line as the direction in which a free magnetic north pole would move if placed in the field. Magnetic field lines may be plotted using a small compass, a plotting compass, or by the use of iron filings and a compass. The magnetic field lines of a bar magnet are shown in the figure. Effects due to Earth's magnetic field have not been included since the Earth's field is relatively weak and would be of importance only at some distance from the magnet. It is important to realize that although the magnetic field has been drawn into two dimensions, the actual magnetic field is three-dimensional. For any magnetic field, the magnetic field lines start at a north pole and end at the south pole. For any magnetic field, the magnetic field lines are smooth curves which never touch or cross. For any magnetic field, the strength of magnetic field is indicated by the distance between the lines. Closer lines mean stronger fields. It can be seen that these properties are very similar to those of electric field lines. The figure illustrates the magnetic field pattern between the north pole of one magnet and the south pole of another magnet. This pattern is similar to that produced between the poles of the horseshoe and magnet. Well, the figure shows the magnetic field between the north poles of two magnets, and the magnetic field due to one magnet opposes that due to the other. The field lines cannot